Okay, let's now start talking about section lesson 11.7 in your book, page 623. This is trigonometric ratios. What is trigonometric ratios? Well, first of all, it's talking about trigonometry. Trigonometry is math associated with triangles and angles, specifically right triangles. And in the function of right triangles, there's three special functions we need to deal with. They're called sine, cosine, and tangent. And I'll explain what those are right here. First of all, assume we have this triangle right here, and it's a right triangle. Okay? And we're talking about angle A. From angle A, there's always three sides. The opposite side, the adjacent to it, and then all right triangles have the long side called the hypotenuse. So for the angle you're talking about, there's always an opposite leg, an adjacent leg, and the hypotenuse. The sine function is the measure of the opposite leg over the measure of the hypotenuse. The cosine is the measure of the adjacent leg over the hypotenuse, and the tangent is the measure of the opposite side over the measure of the adjacent side. Okay, and I've abbreviated these onto the side. A way to remember this is sine is opposite over hypotenuse, SOH. Cosine is adjacent over hypotenuse, CAH, and T is opposite over adjacent, TOA. And those three acronyms put together is SOHCAHTOA. And SOHCAHTOA is the word to remember how these all work together. SOHCAHTOA. Okay? Now, let's use this. Example 1, we're giving a right triangle. It looks something like this. Right triangle, this is 17, S and R, and T, and this is 18, and this is the square root of 35. So they're giving us all the measurements of this triangle, and they want us to find the sine and of each of the angles. So let's take a look right away. Let's do the sine of angle R. Okay, there's angle R, and we know that sine is opposite over hypotenuse, so the opposite of R is, at this line right here, 35, square root of 35, over, well, hypotenuse. The hypotenuse in this is the side opposite the right, so that's 18. And if you get your calculator out and punch that in, you get 0.3287. Okay, let's do the cosine of R. Cosine is abbreviated COS, and sine is abbreviated SIN. So the cosine of R, well, now we're still talking about R, but now we're talking about cosine. Cosine is adjacent over hypotenuse. So adjacent to R, no, this is the opposite. The adjacent one that's touching it is 17 over hypotenuse, same hypotenuse, 18, and we get a 0.9444. And finally, let's do tangent of R, abbreviated with TAN. And tangent, come back up here and look, and SOHCAHTOA is opposite over adjacent. Opposite is, in this example of R, is square root of 35, and adjacent is 17, and when you calculate that out, you get 0.3480. Okay, well that we've done R, well, let's now do T. Let's do the sine of T. Well, it's still, the sine is still opposite over hypotenuse, but now the opposite of T is 17. So 17 over the hypotenuse 18, still the same hypotenuse. And that gives us 0.9444. You'll notice that this sine and this cosine are the same. Okay? Then we'll do the cosine of t. Cosine is adjacent over hypotenuse. T, the adjacent, is the square root of 35. All over hypotenuse, 18. And we did that up here, so it's 0.3287. And finally, we'll do the tangent of t. And tangent is opposite over adjacent. So opposite of t is 17 over adjacent, square root of 35. And notice that the tangents are just reciprocal of each other. And that gives us an answer of 2.873. All right, and we've just looked at a triangle and did the cosine and sine of both of those angles. Okay, and you don't do cosine and sine of the tangent of the right angle because you don't know which one is adjacent and which one is opposite. All right. Now example 2 is real simple. I'm going to give you this picture. Right triangle, and it's got 35-degree angle. Okay? And I want you to tell me what the sine of that 35 degrees is. Now you can't do that with math, you have to use your calculator. So I want you to get your calculator out and type in 35 and hit the sine button and see what you get. You should get something 0.6428, something close to that. Okay? All calculators can do this. All scientific calculators can do this. If you can't do that, I want you to go to Google and look up Web 2.0 calculator. The Web 2.0 calculator is very good at doing these type of problems. And finally, let's look at example 3. Example 3, they're asking us to find the measure of angle J, okay, to the nearest degree, and here is the triangle they're giving us. Here's our right triangle. They tell us that that side is 9, this side is 6, and that is angle J right there. Okay? So we're trying to find what this is right here in degrees. So to do that, I first look at what do I know? Well, starting from J, I know, what do I know? I know its opposite side is equal to 6. And I know its adjacent side is equal to 9. So if I go back and look at my SOHCAHTOA rules, which one of these functions has opposite and adjacent? Well, I look at that, and that is my tangent. So I'm going to use the tangent function to figure this out. I'm going to say the tangent of x, not of x, of angle J, we've labeled it as, the answer is x, but the tangent of J is equal to opposite over adjacent, and I know the opposite is 6, the adjacent is 9, okay? And that can reduce down to 2/3. So I've got the tangent of J is equal to 2/3, okay? So now how do I get that into a degrees? Well, I go into my calculator and I do the opposite, or the inverse function. Mathematically, you can write the inverse function as this. J is equal to the tangent, and you put a -1 there, which means the inverse function of tangent, and 2/3. And once you've done that and punch it into your calculator, you get an answer of 34 degrees. Now, you'll have to learn how to punch this into your calculator. Some calculators, this is called inverse tangent. Some calculators called arc tangent. Okay. On web calculator, it is like this. ATAN stands for arc tangent, which is the same as the tangent minus 1. The good thing about the Web 2.0 calculator is that you will see this function, but it also shows you this nomenclature up above. So you'll see that this and this are the same thing. Okay? So once again, the tangent of J is equal to opposite over adjacent. But if you want to turn that into degrees, you have to do the inverse tangent function, and that gives you 34 degrees. Okay, let's look at number 4 now. On number 4, we're trying to solve a triangle. And what does solving a triangle do? It means take a look at a triangle, figure out all the missing parts, and fill them in. And the missing parts can be angle measurements or side measurements. Okay, so let's say we're given this guy right here, right triangle, C, A, and B, and we know that this angle is 38, and we're given this is Y, this is X, so we don't know either one of those two, but the hypotenuse is 12. So the first thing we can do is we can figure out angle B. We've got to figure out 3 things. We've got to figure out angle B, because we don't know it. We know angle C and we know angle A. We know 12, the hypotenuse. We've got to figure out the 2 legs, X and Y. Okay, so let's start with angle B. Angle B is equal to 180 minus 90, which is the C, minus another 38, which is what we were given. And that leaves us with 52 degrees. So we've just solved one piece of the pie. It's 52 degrees. Now let's figure out X. When we're doing X, we do what? We say sine of 38 degrees, angle A, is equal to opposite X over hypotenuse 12. And now we've got a equal sign here. I can multiply both sides by 12 to get X by itself. And so I get 12 times the sine of 38 equals X. And when I punch that into my calculator, I get X is approximately 7.4. So we now have solved for X. Let's try Y. Y, okay, this time for Y I can't use sine because I got to have the adjacent side, so I'm going to use cosine. The cosine of my 38 degree angle is equal to my adjacent side, Y, over 12, and I can multiply both sides by 12 to get Y by itself, and I get 12 times the cosine of 38. And I punch that into my calculator, and I get 9.5. And I've just solved the 3 missing parts of this triangle.